don't think it's negative unless we start
Uh,
talking like a 2D plane. It should be forward, like or to the right.
yeah, so it doesn't matter whether it's forward or backward. Obviously, if they will give us the free hand, we're gonna make something like maybe this is the so-called red light, and
Mm-hmm.
the driver is traveling at 18 meter per second. So this is 18 meter per second when she
Mm-hmm.
sees the red light. So, and remember that she is 20 meter from the intersection when she sees the light. So I'll say that this is 20 meters. Okay. And the deceleration is 3.65 meter per second square. But if it takes her 0.35 seconds just to apply the brakes, what does that mean?
For her to apply the brakes, and that means that's additional time that's not added, right? That she's going 18 meters per second,
Very
right?
good. Very good. This is called reaction time. Sometimes they will say that if a reaction time is fine, because obviously as soon as you will see the red light, you have to process, your mind has to process, it gives you signal to your feet and you have to apply the brakes. So that thing takes 350 milliseconds. So in that 350 milliseconds, she's still traveling at 18 meter per second, right? In the same
Mm-hmm.
direction. And if she travels with 18 meter per second in the same direction, what is the distance traveled in that case?
18.350 seconds, right? So it'd be
18 point?
or the amount of time that she's traveling for that distance. 18.
Distance is speed times time, right?
Mm-hmm.
So 18
Yes.
times 0.35, which is 6.3.
Mm, it's 6.3. Okay, fine.
6.3 meters. So for 6.3 meters, she was actually, what do you call it as? Yeah, she went just like that, even though the brakes are not applied here. So her brakes got applied at this position where this is 6.3. So the for the remaining time, remaining distance, which is 20 minus 6.3, which is 13.7 meters, we have to find whether we have to find that after how much time she's gonna stop, right? Because after all, uh, what do you call it? I'm sorry, not the time. We are given,
She has acceleration, right? I mean deceleration of 3.65 meters per second squared.
yeah, so we are given
So
initial speed, we are given deceleration. We know that she has to stop, so final velocity is zero. So keeping these things in mind, we have to find out how much distance is she gonna take, is she gonna cover. Because if she covers more distance than that, then 13.7, she's definitely overshot the red light, right?
yeah.
Okay.
So we have 13.7 distance to cover, and then we're going at an acceleration of 3.65 meters per second squared. Is
Deceleration, yeah.
acceleration or
Deceleration.
deceleration? So it's negative, and then okay, and then so to find acceleration, one of the formulas
So no,
was
why are we finding acceleration?
or not acceleration, like to find we have to find time, right? So how long will it take
No,
her?
no, 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 no. Okay, the question is, will she be able to stop in time? It sounds like we have to find the time, but actually we have to find whether she will stop within 13.7 or not, 13.7 meters or not. So
So would you just
what?
divide it by 3.65? Is that not
Uh-huh, uh-huh, uh-huh.
no?
What we have to find is, in this situation, what is the distance covered?
Find distance.
And then compare this distance with
13.7.
13.7. Remember,
Oh,
13.7 is not the distance covered. We do not
it's a
know when
distance that
she's
should be covered.
exactly. That's what we want to verify.
Okay, so 13. So So 3.65 meters per second squared. How long will it take for velocity to reach zero? So I
So
guess we
we
can use the displacement formula then, right?
exactly. So displacement means equation 2 and equation 3. But equation 2 has time and time is not given. So I think we have to resort to equation number 3.
Number three, isn't that velocity squared?
Exactly.
And then you would just have to alter it so that it fits whatever we're looking for. Yeah, okay. Fine. So that would be
Which is
give me a second, sorry.
mm-hmm.
So S is equal to initial squared minus final squared, or yeah, it's final squared divided by negative 2a, right? Yeah. So in that case, it would be to find this. The initial velocity was 18 meters per second minus 0.
Mm-hmm. Final is 0.
So negative 2, negative 4. No, negative 3.65. That's negative 4 is the last problem. Negative
Mm-hmm.
3.65. So it would be 2 times 3.65. 7.3. And so around 2.465. Wait, what? That doesn't make. Wait, I can't. That doesn't make any sense. You're
This
trying
is
to find. Hmm?
this is square of 18. Let's do it in
Keep
stepwise.
forgetting. Yeah. Okay. I keep forgetting that it's 18 squared. So it would be 18 divided by 7.53. It would be 18 squared, which is 324, right? 324
Yeah,
divided by 7.3, which is around 44.38, which means
44.
she
So
won't make it.
sh yes, definitely she's gonna overshot by almost twice the distance, even by more. So yeah. Shall we solve this question? Makes sense.
Okay.
Okay. All right. I'm gonna pull up one question, but we are gonna not gonna solve it together. That is for you to try as a homework. Question number 36. So that's a difficult question. Try to solve it. Uh, uh, if it's not solved completely, you don't have to worry about that. Just come with whatever you have solved, and we'll take it forward together. All right.
Okay.
Okay. Next concept is of the relative velocity, which is barely gonna take 5 minutes, but it's really powerful. Which I think you told me you know the theory about it, which was exactly what I would have told you. So I'm not gonna tell you the theory, but just the mathematical part. So relative velocity means usually whenever we say that okay, the car is moving at 2 meter per second. So we always have that speed with respect to ground, right? We always have anything which we say by default is with reference to the ground. But what if I want to say something in reference to another moving object? For example, assume that two players are going side by side at the same velocity of 5 meter per second. And this is A, this is B. So when A looks at B, and assuming that, kind of maybe the other part, hypothetically, he's not seeing, he will feel that he's at rest because the other person is kind of together with him. So there is no relative velocity between them. Can I say this? There is no relative velocity between them.
Hmm.
So that is the concept of relative velocity. Relative velocity means finding your or an object's velocity with respect to another frame, not the frame, another object which is also moving in some direction. This is the simplest case of relative velocity when A and B, which are parallel, which are moving along the same track towards the same side with the same velocity, have their relative velocity with respect to each other as zero. So, what is the formula? Relative velocity, this is how we write it. Relative velocity of A with respect to B is the actual ground velocity of A minus the ground velocity of B.
Oh, okay. That's easy to remember.
So the ground velocity of A is 5. The ground velocity of B is also 5. So relative velocity of A with respect to B is 0, which we just talked about because A is not moving anywhere with respect to B. They are all together. Make sense?
Mm-hmm.
So another scenario can be, let's say there are two friends who are moving towards each other at let's say 2 meter per second and 3 meter per second. This is A, this is B. What is the relative velocity of A with respect to B?
So 2 minus 3, so that's 5, right?
5. And what is the direction?
In um
East, right?
yeah,
Because
east.
you have clearly taken west as a negative sign, and that's why you got negative here. And our answer is
Mm-hmm.
positive, it means that we are talking about east. And what is the relative velocity of B with respect to A?
So 3 -3 minus 2 is -5.
Exactly.
-5 west.
Negative 5, right? Over on the left side. How
Mm-hmm.
is that helpful for us? Remember that train question which we did yesterday? I was talking
The
about
which one?
two trains are moving towards each other
Oh,
at the same
yes.
speed. Yeah. I told you there is an elder brother of it, and the elder brother looks like this now.
If they're at different speeds and they're going
Exactly.
to meet.
So let's say hypothetically the distance between them is, I don't know, maybe 1 kilometer. And let's say this is moving with what is a fair speed for a train, maybe 120 mph. And this is, let's say, 110 mph. And I'm interested in the time when they meet. When they meet. So if we use the concept of relative velocity, just like I said, this can be solved like this. So you have to remember this so-called analogy or maybe a corollary of the formula of the distance is equal to speed times time, or speed or time is equal to distance over speed, is that time is equal to relative distance over relative speed or velocity. Velocity actually, not speed. So you know the concept of relative velocity already, but what is the relative distance? Just the distance between those two guys. That is a relative. Because obviously, what is your distance with respect to your friend? So that's your with the distance between your home and your friend's home, right? So relative distance
Mm-hmm.
is just the distance between them. And if we know this concept, don't you think we can find time so easily? Because the relative distance is 1,000 meters and the relative speed is 120 plus 110.
Yeah.
We got the time.
So relative distance is 1 kilometer, and then relative speed, not relative time.
So time is not relative, time is time.
Yeah. So it would
Mm-hmm.
be relative velocity, right?
Mm-hmm.
Okay, and we know relative velocity is 120 minus 120 minus 110.
Minus 110. Yes,
So
yes, that's correct.
yeah, so that would be 120 plus 10, which is what, 230. So it would be 1 divided by 230. Wait,
1 kilometer. Make
but
sure
kilometer.
to convert the units.
Okay, and meters per second. Okay, so in that case, it'd be 1,000. 1,000 divided by 230, which is 4.35 seconds. Okay,
Mhm.
fine.
So, pretty helpful if we know this short concept, and especially in such questions. All right, excellent. We're moving to the other part of kinematics, which is free fall. Okay, what is free fall?
When an object is dropped, in the force of gravity is working on
Dropped or thrown in the air. So,
it.
in other words, if the object is only under the influence of a gravity, it's under free fall. Remember that in all our questions, most of the questions will ignore the air resistance, so you don't have to worry about that. All right, what is the value of the acceleration due to gravity?
Thrown, it's thrown or dropped, right?
You just have to remember that whenever an object is under the influence of gravity, only it is under free fall. So whether it is thrown, dropped, projected, uh, anything.
But if
But
it's thrown,
hmm,
then wouldn't it have the effect of the throw on it? The
yeah,
force of the throw.
that's correct. But we are talking about the motion in I mean, in a broad perspective. So the if you're thinking that we have applied some force on it and went, remember that force is only for the fraction of seconds, but for the entire, okay, remember that let's say you are here and you are throwing a javelin, for example. And once you throw the javelin, remember always that our physics starts from this point when you have thrown, not when the
Hmm.
javelin was in your hands. And when you went your hand like this and it got released. Some physics was applied over there, like some force, some work done. We are not worried about that. As soon as the javelin is released from your hand, it is under free fall.
Hmm. Okay,
Okay.
fine.
What
So
is the
you just
ax?
don't worry about that.
Yeah,
All right.
don't worry about that. That's a good question, but
Okay.
don't worry about that.
Hmm.
Okay, what is the acceleration due to gravity? Number?
9.8 meters per second squared.
What's the direction?
Down.
Okay. Can it change somehow in some situation?
No,
Okay.
never.
All right. Remember that all the equation, the theory is done. All the kinematics equation are equally applicable here, except for the fact that the A will now not be given outrightly. You have to understand that it is always 9.8 meter per second squared downwards. And remember the sign conventions. It is always downward. So make sure that if you are taking your upward direction as a positive, then
Then
acceleration is
downward
considered.
directions would be negative.
Exactly, exactly. That's very important. All right, all good. Let's start with a question. Okay, all right.
Fine.
So the question says that there's a ground over here, there's a ball over here. The ball is thrown from the ground level at 8 meter per second. My question to you was, what is the velocity at 1.5 seconds?
Velocity at 1.5 seconds. Okay, fine. So we know velocity, we know acceleration, and we know time. So first equation would work best for this, right? If I'm not mistaken. So initial velocity, acceleration time. Yeah. So final velocity would be zero, wouldn't it,
For which one?
for this problem? Would final velocity be zero?
We have to final means you're saying that after 1.5 seconds the velocity is zero. What do you mean by final?
Well, okay, so the formula is v is equal to initial
Hmm.
plus acceleration time. Wait, but the v is not final, is it? It's just general?
For you, that is the final.
Okay,
You,
that's fine then.
after
Okay.
1.5 seconds, you are finding V. So for you, that's final, right?
Mm-hmm.
Okay.
Okay, so, but then in that case, what would initial be? Oh, 8 meters per second. Okay,
Mm-hmm.
cool. I saw that. Mm-hmm.
Mm-hmm. Oh, testing me.
9.8.
Okay.
Yep, you caught me. 9.8 times 0.5, 14.7 plus 8.
Okay, so I'm interested in hearing that which equation you used first off. So I heard that you use V final as V initial plus AT. Now I'm
Mm-hmm.
interested in you said that you're finding V final. Okay. What is V initial?
8 meters per second. So
Okay, what is
8
A?
plus 9.8 times 1.5.
No.
Really?
What is the mistake?
It's acceleration times time. So, and all the units are correct.
Mm-hmm. Yeah.
Did I use the wrong equation?
No. The answer is on the board.
It's negative 9.8.
Please don't make these mistakes. They are gonna change everything. Always remember, I have a habit of putting the sign convention over on the left for my reference. So I mean, you have taken upward direction as positive. So I'm gonna write it like this so that I keep a track of what is up as positive and down as negative. Okay, what is the answer?
6.7. It's
No.
14 or negative 6.7.
Okay,
Yes.
good. Negative 6.7. What is the meaning of negative?
It means that it's velocity in a downward direction.
Exactly. So don't you think it means how is the motion? The motion is like 8 meter per second, thrown up, 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 slow, 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 stop. Down, 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 down. So this is the instance where the ball is now, because we know that it should go, it has to go up. It stops and it comes down. And this is where we are finding somewhere its velocity as 6.7 meter per second, because this is where its position is now. Because for a fact we know that it's negative, so obviously it is coming down. So it is not on the upward trajectory, but on the downward trajectory where it is. Makes sense, right? Practical scenario.
Makes sense.
Okay.
Hmm.
Time when it stops. Time when it stops is in time when it stops at the top. What is the time?
It's a parabola, isn't it? But I
Oh,
don't think that'll be written.
what is parabola?
A quadratic like quadratic graph.
It goes
Is
up.
it
Like, I
not?
have shown you so that you see it clearly. I mean clearly. The whatever path it goes up, the same path is gonna come down. Remember, there is no tilt. I'm throwing it exactly vertically, so it goes up, comes down, same path. There's no curve like this. That will come later. That's projectile. That comes later. Right now, it is going up, down. That's it.
Okay. So time when it stops would be um hmm, when final velocity is equal to 0.
Okay, fine. I agree with you. So what is the time?
Yeah. Negative 8 is equal to negative 9.8 t. Right. So that's 8 divided by 9.8, which is around 0.81.
Okay, is this what you used?
Yeah.
Very good. 0.81 is the correct answer. What is the unit? Seconds, of course. Rounded
Seconds.
to two
Yeah.
decimal places, 0.82. And now it makes sense, right? In
Mm-hmm.
0.82 it is here. So obviously,
At
okay,
1.5,
okay,
it should be going
okay,
downwards.
yeah,
Yeah.
correct. Okay, two things, two important things for you. If it takes 0.82 seconds to go up, how much time does it take to come down?
The same time.
Exactly, that should be in your notes. That if there is no air resistance, always remember that the time to go up is same as the time to come down. Point number one. Point number two, what is the velocity when it comes down and is at the same level, at its launch level as the yellow arrow?
What do you mean by that?
What is the velocity when it is about to hit the ground? Comes back.
Um, hmm.
Equal and
It's
opposite.
equal. Oh, that's one of Newtonian laws, right? One of the three laws of motion. Okay, that it will
Laws of
always have
motion.
an equal opposite. Or laws of
Newton, no,
uh,
that has nothing to do with
just
this. This is
Newton's
energy
law.
conservation. This is energy conservation. No, 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 no. This has nothing to do with Newton's law. It is energy conservation, but you don't really have to think about it in energy conservation terms. Try to think about it like there is no, I mean, there is no air resistance. So obviously, the velocity with which I have thrown it is 8. Down, 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 0. Up, 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 8. Once again. So it's just like time. Time in that duration is same as the time to track down. So the time should be same. That should come in your notes. And the second thing is the hitting velocity will once again be same as the launch, or I should say speed actually, because they are in different direction. But you get the idea that the speed of the launch is same as the speed of the of hitting the ground. Why is this important? I'm going to use this concept in projectile as well. So at that time, we should not have this confusion that why is this same. So time to return is equal to time to go up, and the speed at the time of hitting the ground is same as the speed of launch. Please remember, this is applicable only when there is no air resistance,
But you said
which
most of the time they ignore air
which
resistance, don't they?
99% will be the case.
So the launch speed um, of is equal to the landing speed, or I
Correct.
guess
You can say that.
equal and opposite forces, but only with no air resistance. Okay, cool. So for homework, I'm just doing that one question, right?
No, you're doing another
Oh,
question that is coming.
okay, fine.
Okay, so you do not have to work for 1 second or 3 seconds. Just work for 2 second case. That's question number one. And question number two is an extremely conceptual question, which I definitely want you to answer. Uh, I'm gonna add on the same page actually. Because this is a conceptual example. There is a figure, but I won't give you the figure because figure will ruin the question. You can make the figure, and this one doesn't need a pen and paper. You just have to tell me, just think about it and tell me what do you think is the answer. The other one is the numerical, and this one is a little bit challenging. Feel free to take help, online help if you want. Otherwise, I'm here. We'll discuss with this as well. I think we are meeting today evening as well. So today evening we'll
Yeah.